Assalamu alaikum. I'm Professor Dr. Haider Jawad Mubarak. This is a presentation to the topic of comparative anatomy of the gastrointestinal tract. Generally, the gastrointestinal tract is formed of many parts, including the mouth or the oral cavity, then the pharynx. After the pharynx, there is the esophagus, then the stomach, then small intestine, large intestine. In addition to these parts, the gastrointestinal tract contains many accessory organs as the tongue, the mouth, the teeth, and oral glands. Also, accessory organs include the pancreas and liver with the gallbladder. During embryonic development, the origin of the gastrointestinal tract is similar in earlier stages of development in all vertebrates, and that's why you may find researchers doing researches on the gastrointestinal tract of the embryo of rat or birds, because in early stages the developmental stages are similar, but was going on that in later developmental stage modifications occurred for the embryonic structures of the gastrointestinal tract, and these modifications are according to the type of food of certain species and the abundance of food to that species. Generally, the early embryonic gastrointestinal tract is formed of three parts, which are foregut, midgut, and hindgut, as you can see in this figure. The foregut will form the oral cavity, pharynx, esophagus, and the stomach, and the upper part of small intestine, and also the foregut form the liver, bile duct, and pancreas, while the midgut form the lower part of the small intestine and the upper part of the large intestine, and the hindgut form the lower part of the large intestine. All these three parts of the embryonic gastrointestinal tract, the foregut, midgut, and hindgut, are in a form of a canalized or a tube with a lumen. But later on, the lining epithelium of the lumen of the foregut, midgut, and hindgut, the lining epithelium will proliferate, and thus the tube, foregut tube, midgut tube, and the hindgut tube will form a solid cord by proliferation of the lining epithelium. And then after, during embryonic life, recanalization of this solid cord will occur, resulting in formation of the hollow gastrointestinal tract with a lumen. And because of the process of recanalization, we may find various forms of modification. For example, in that figure, the recanalization results in division of the lumen of the gut into two spaces, or there may be a narrowing of the some kind of the narrowing of in the lumen of the gutty tube, or maybe the gutty tube in certain region will not be canalized in a species, and that leads to obstruction of that part of the gutty tube. So we will describe in brief some of the morphological criteria related to the topic of comparative anatomy of the gastrointestinal tract, starting with the oral cavity. The oral cavity may be short or long. It may be short as in fish, long as in tetrapod. In mammals, as a form of tetrapod, the mouth, the oral cavity is modified for mastication, which is movement of the jaw to macerate the food, and also in mammals the oral cavity is modified for suckling of a fluid. Modifications of the oral cavity in variable vertebrates as a topic in comparative anatomy may include modifications in structures that are lying in the oral cavity, and we will start with the teeth. This figure shows you that the teeth in all vertebrates is formed by from inside by a dentin, and this dentin is surrounded by the white enamel. Although this is similar structures in the tooth of all vertebrates, but the teeth of vertebrates differ in their number and their distribution, in their permanency, or in their attachment or shape. There are even some vertebrates that they don't have tooth. They are toothless vertebrates, just like birds, turtles, and agnathian. And what's happening is that during embryonic life, these vertebrates will lose the primordium that form the teeth, and therefore this primordia will degenerate, and these vertebrates will not have any tooth. Or, on the contrary, the teeth may occur or may develop, and thus we may have this different comparative morphological criteria. For example, regarding distribution of teeth, some of the fish, as this figure shows various extension of the teeth. You can see here in this fish that the teeth distributed all over the mouth and may extend posteriorly near to the pharynx. In some tetrapods, for example, this is a frog, you may find that the teeth are already seen in the roof of the oral cavity at the palate bone. In mammals and crocodile, usually the teeth are orally distributed into the jaw or onto the jaw. So there is a variability in the tooth distribution in regard to regeneration and degeneration of the embryonic primordia forming the teeth. Regarding permanency of the teeth, the mammals usually shows two sets of teeth during their life, decidual milky teeth and permanent teeth. But other vertebrates may replace the teeth continuously in waves. So whenever they have a fallen teeth, they will have a new teeth replacing the fallen teeth. Regarding the morphology or the shape of the teeth, mammals usually have variable shape of teeth. They have incisors, canine, premolar, and polar teeth. While in other vertebrates, we may find that all the teeth are the same, and in that condition, it is called homodontition, as in shark shown in this figure. The mammals' variable sheath, as canine incisors and molar premolar, are called heterodont dentition. According to the proposal that I am making in this comparative anatomy for the teeth, you may find sometime human with having multiple or supernumerary teeth, and this is a surprising phenomena that may raise a question why. And this is, as I said, because some the earlier stages of development shows disappearance or degenerations of some of the primordium, or maybe the primordium of the teeth will continue to develop, and therefore we may have, as a human, only teeth on the jaws, but we may have supernumerary teeth due to the fact that in embryo we have the primordium of these teeth, but what's going on that as a human these primordia will disappear. If they not disappear, they will give rise to this phenomena, which is supernumerary teeth. And related to the comparative anatomy of the tongue, as you know, has many functions. It captures, manipulates the food, it tastes the food, helps in swallowing, and in dogs it helps in thermoregulation, which is surprisingly a very strange function for the tongue. You know, when the dog is running, it's protruding his tongue outside because the saliva will evaporate from the protruded tongue, and this is a way to decrease the temperature while the dog is running. And so in dog, the tongue may act as a thermoregulation function, because actually the sweat glands in the dog are not well developed. Also, the tongue function is cleaning in some vertebrates, and the tongue function is to help for speech and that is of course a function that is only seen in human. Comparative variability of the vertebrates' tongue are many. Some of the vertebrates may able to extend the tongue outside the mouth as in snakes. Others vertebrates will not be able to extend the tongue outside the mouth, just like the turtles. Regarding the human as a mammal, the tongue is attached to the floor of the mouth by a fold of mucosa which is called the frenulum, and this is it, the frenulum. But in spite of that, the frenulum attaching the tongue to the floor of the mouth, the human can extend the tongue outside the mouth. However, variation may occur. For example, in that congenital anomaly shown in this figure, you can see that the frenulum is connecting the interior part of the tongue to the floor of the mouth, and in that condition it's called tie tongue. The human could not protrude his tongue outside the mouth because of this abnormal frenulum. The frenulum normally should not prevent the tongue from protruding outside the tongue because it is very short and it's lying posteriorly, but in that condition the frenulum is long and it tightening the tongue to the floor. Of course, this is an abnormality that could be corrected simply by incision of this frenulum. This is also a congenital anomaly or variation in which you have a very long tongue. Surprisingly, it is not familiar in human. In regard to comparative anatomy of the oral glands in between different vertebrates, oral glands in different vertebrates may secrete saliva, or it may secrete poisons, or it may secrete anticoagulants. The saliva is the secretions of the oral gland that is usually seen in human, that is seen only in other vertebrates. The saliva lubricate the foods and make it soluble if it was dry food, and also the saliva maintains hygiene in the mouth, and the saliva in human contains amylase enzyme that digests starch, as in starch of bread. That's why if you are eating bread, you will feel that the bread is sweet in color because amylase in the saliva will digest the starch of the bread, and so you'll feel the bread as a sugar feeling, or you will taste the bread as a sugar taste. So other vertebrates may have oral glands that secrete poisons, just like snakes, lizard, and some mammals and vampire bats. The oral gland secretes anticoagulants to make suction of blood easier. In regard to embryology of the pharynx, as we said, the general embryological structure of the gastrointestinal tract and even other systems are similar in vertebrates at early embryonic stages, but later development will show modifications according to the requirements. And the pharynx is a good example of that in the gastrointestinal tract. In embryo, you may find gills, which are pouches from the pharynx. In fish, in chick, in human, and other vertebrates. You can see this is a chick embryo, and you can see slits homologous to fish gills, and these slits are also seen in human. But what's going on that in fish, these slits from the pharynx, which are called slit pouches or branchial pouches, will form respiratory organs for the fish. But in other vertebrates, for example, the human, the gill pouches will not form a respiratory organ, but actually they will form pouches protruding from the pharynx. For example, in a human, you may find the eustachian tube, which is the auditory tube, as a pouch protruding out of the pharynx to be connected with the middle ear cavity. This eustachian tube is a pouch that is derived from the gill pouches, but it will form only a eustachian tube. It will not form a respiratory organ just like in fish. Regarding the comparative anatomy of the esophagus, you know the esophagus is a muscular tube that connects the pharynx with the stomach. You may find a variation, for example, in pigeon, which is a kind of bird. In pigeon, you may have a dilatation in the esophagus, which is called the croup, that makes the pigeon able to store the food in this pigeon during eating. Regarding the abnormality of the stomach, I just want you to remember, before a while we said that the gutty tube, foregut, midgut and hindgut initially contains lumen, and then the lumen will be closed or obliterated because the mucosa will proliferate and close this tube to form a cord-like structure. Then there will be recanalization for formation of the lumen of the gutty tube. Here, this phenomenon is very important to be remembered in discussion of the comparative anatomy of the stomach, variability between various species. The stomach is a muscular tube, as you know, generally, located at the lower end of the esophagus. It stores and macerates food and also secretes some digestive enzymes of the food. Variable vertebrates shows variability in the stomach. For example, some vertebrates may not show a well-demarcated stomach, as in cyclostomes. Other vertebrates may have a well-developed stomach, but it is formed of two parts. For example, in bird, you may find that the stomach is formed of two parts. One of them is called the proventriculus, and the other is called gizzard, and these are shown in this figure. Or even other vertebrates may have a stomach which is formed of more than two parts, as in sheep, which is a ruminant. The stomach in sheep is formed of three parts, which are the reticulorumen, the omasum, and the abomasum, and these are shown in here. And you can see that such a subdivision of the stomach into many parts is related to the process of recanalization of the gutty tube, specifically the foregutty tube, during development. In a human, the recanalization of the foregutty tube in the region of the stomach will produce only one lumen, which is the stomach lumen, while in bird or in ruminant, the sheep, the recanalization will result in formation of more than one part in the lumen of the stomach. Regarding the comparative anatomy of the stomach, of the intestine, you know the intestine is a term referring to the small and large intestine that is in between the stomach and the final opening of the GIT, which is either the anus or cloaca. The intestine in various vertebrates may vary. Some vertebrates may have a short and straight intestine, not long and coiled intestine just like of a human. An example of such vertebrates with short and straight intestine is the intestine of some fish. This intestine of fish may contain from inside the spiral the mucosa in a form of valve. Other vertebrates may have a coiled small intestine and a straight large intestine, such as the intestine of amphibia. Other vertebrates may have a large intestine that ends into the cloaca, as in bird. In mammal, which including the human, we have a large or a long coiled small intestine and also a long coiled large intestine. Also, the large intestine is not long as the length of the small intestine. You can imagine that the variability in the morphology of the intestine and various vertebrae shown in this figure may make us referring to the abnormalities that they could be seen in the intestine of a human. Congenital anomalies in the human may produce malformation that simulates some kind of intestine in other vertebrates. Regarding the comparative anatomy of the liver and gallbladder, the liver have many functions, but one of these functions is bile, and the bile is stored in the gallbladder. Surprisingly, some of the vertebrates may have no gallbladder, just like the birds. Some vertebrates may have a blind loop, which is called ceca. Such a blind loop in some vertebrates may add a surface area for more absorption. Some of the vertebrates, just like fish, may have a blind loop near the stomach or near the pylorus of the stomach or near the duodenum. Others, or most of the others, will not have such a ceca. And this is an example of the blind loop which is attached to a part of the gastrointestinal tract. Finally, the cloaca. The cloaca is a chamber at the end of the digestive tract. It may be connected with the large intestine and also connected with the urinary system and with the genital system. And you can see this is a cloaca which is open to outside, and this cloaca is connected with the intestine and also connected with the ureter and connected with the genital ducts. And such a cloaca could be seen in many vertebrates like birds. The outer opening of the cloaca is called the vent. In a human, as an example of mammal, there is no cloaca. The intestine is open to outside by an anus. This is in brief the variation in the gastrointestinal tract among the vertebrates with referral to the human anatomical configuration. And in summary, the gastrointestinal tract therefore could be attributed or must be attributed to the functional need that is dependent on the type of food that the animal is eating and to the abundance of food that the animal is facing. Thank you very much.